Hi everyone, and welcome to my talk on orchestration in the Openstack Cloud. My name is, sorry, I think it doesn't work. Okay, my name is Simone Soldateschi. I'm a senior DevOps engineer in Sydney. I work at Rackspace. I've been working as a software engineer, then systems engineer, and then I've merged all those things in a DevOps role. What do I do? Essentially, I work with developers, mainly Python and Ruby developers. I dig into their source code of their application, and I work on task automation in the Openstack Cloud that we use at Rackspace. That is what we are going to cover today. We are going to discuss pipelines to be containers, a full stack. We will see a full stack to run all the things. We will discuss how to orchestrate every component and to do service discovery to go live. Usually, when you think of developing and deploying application, you develop, you test, you run UAT, QC, and then you hand it over to someone who provision and deploy your application on staging and live environments. And that is the part that I'm mainly concerned about. Question is, why? The point is that all configuration management systems tell us that we need to write code to tell systems how to manage themselves, which is defining the desired state of systems. And unfortunately, that is not always true. Let me give you a trivial example. Let's discuss a trivial issue. Let's say that in our cookbook, playbook, or wherever, we define a full user. That user has to exist on nodes that we manage. Then we run our automation, and the full user gets created on managed nodes. Okay, that's great, it works. Then we realize that we don't want the full user anymore. We want a bar user. So we comment full user, we remove it from our configuration. We run Chef Client, Ansible, Puppet, whatever you want on systems. And what you get is that you get full and bar on nodes. So wait a second, we define the desired state, and we don't have that desired state on systems that we manage. So this is just a very trivial example. There are many ways and many simple hacks that we can do to prevent that from happening. But even though that is mostly due to complexity of systems that we manage, to the development workflow, and most importantly, idempotency. That is not always honored. Ideally, things should be simple, repeatable, and versioned. If we get there, we are done. So let's see how we can do it. First of all, you need to pick up a Linux distro to run stuff on. Although CoreOS is not my favorite distro, it's really easy to set up a core node in the cloud. It's really easy, especially if you want to run a CoreOS cluster, a high available CoreOS cluster. It's really easy to run in the cloud. You just need to provision 3 cloud servers, and you're almost done. All that you need to do is to beware that an etcd daemon is running on every CoreOS host, and that allows you to tie all things together in a CoreOS cluster. Essentially, you just need to run car on the command line, get a token, pass that token to CoreOS nodes, and new nodes participate in the CoreOS cluster. So it's really easy. If you want to scale up, scale down, maybe using a scaling group, you can do it's really simple as that. If you run CoreOS, obviously you want to run Docker. And the first thing that you need to know about Docker, and I'm pretty sure all of you already know, is that in a Docker container, you should run one process only. I've heard many systems administrators asking, how can I SSH into a Docker container? It's not a virtual machine. It's a container. You cannot SSH into it unless it's an OpenSSH server, obviously. How can you build a container? You could use a Docker file. A Docker file works great. It's really easy to understand. Anybody is able to understand what it does. It's just a script. It works perfectly. It provisions all the things in a container. But wait a second. Didn't we say that scripts are evil? We are supposed to use configuration management systems because Ansible, Puppet, Chef provides you with an abstraction layer. You don't need to care if you are managing an Ubuntu Debian-based machine instead of a Red Hat. If you manage a Red Hat machine, you need to replace apt-get with yum or whatever you want. So it's good, it's very simple, but you just did a step back. That is obviously a suboptimal solution. How can we improve that situation? Essentially, let's say that you are able to write a JSON file which describes many tasks that you need to perform in order to build a container. And after that, you want to run, say, some playbooks. Maybe you are very fluent in writing automation with Ansible, so you write playbooks. You can upload upstream JSON and playbooks on a Git repository. Then Jenkins kicks in, and Jenkins fetches a JSON snippet from GitHub, and it feeds Packer. Packer is able to understand what you want it to do by parsing the JSON snippet. In that case, I specified that I want to build a Docker container based on a Debian ISO image. Packer downloads the ISO image, and it starts the Debian installer for me. And it types in the Debian installer commands and select things on my behalf. That's great. At the very end, when I'm done executing all JSON tasks, Packer is able to run Ansible and to run all playbooks that I uploaded on my Git repository. That's great. I've just created a Docker image, a Docker container, which is portable. It leverages Ansible, so you have an abstraction layer on top of it. You don't need to use Dockerfile anymore. And you just mixed and used a few interesting tools that are already available. OK, that's great. You have a container. Now you need to share it. You can store it on public hub if there are no secrets there. Or you could run a private registry, which is a Docker repository that you can run, guess where? In a container. It's really easy, just one command. You just need to run Docker run registry and specify the port that the registry has to listen on. That's it. Let's discuss about the full stack that allows you to run all these things. You need to have, obviously, bare metal servers. Then you can run OpenStack on top of that. CoreOS cluster is really easy to provision a cluster there. And you have containers for free with a CoreOS cluster. How do you provision all these things? Actually, for bare metal server, it's an act of faith. They exist. I work at Rackspace. They exist somewhere. I need to provision an OpenStack layer on top of that. OpenStack Ansible deployment is really a smooth way to deploy OpenStack on servers. You can use Vagrant on your laptop for developing purpose, or Hit if you are managing the Openstack Cloud, and then you can orchestrate containers on CoreOS cluster. Let's discuss briefly how you can orchestrate all the things together. To provision CoreOS cluster, as I said, you can use either Vagrant or Hit, and you get the NHL-able cluster. If you want to orchestrate all the things in the CoreOS cluster, you could leverage Docker Compose. You might be familiar with Fig, which is the old name for Docker Compose. And what you need to do is just to write a YAML file which describe what you want to achieve, what you want to get in your cluster. You define your infrastructure, and you define the desired state of what you want to get. You don't care where a load balancer, a database, a web node is running on. You just state that you want a load balancer, a database, a web server running in the cluster. That's it. It runs somewhere. If you delete, if you destroy, if you nuke the CoreOS host on which the container is running, it's really easy to move the destroyed container somewhere else. Now you need service discovery. Why do you need service discovery? Because the first question that arises when you are managing the dynamic environment is a question like a web server is spun up and it asks where is the DB server for this specific environment? Or an HA proxy might ask where are the web nodes for this environment. You might leverage say Chef server, but think a little about that. If you leverage Chef server, you get all the information because Chef server knows what's running in your infrastructure because it got information from Chef client, and Chef client ran maybe 30 minutes ago. So you have information that are 30 minutes old. If you leverage, say, etcd, which comes for free in a CoreOS cluster, you get fresh information. So you provision a web node. That node registers a key value pair in etcd. You can think of etcd as a dictionary, essentially. It's just a set of key value pairs. And when a load balancer wants to know where are its nodes, just have to query etcd and get the value for that key. And do some stuff. You just need to write a configuration file, check if syntax is correct, and reload configuration dynamically. Okay, we're almost there. Let's discuss about the last bit being the CICD pipeline, which allows you to go from a development environment to staging and then live. You have a developer which runs Vagrant, CoreOS, and containers to run all the things. When the developer is happy, he pushes upstream the source code. Another developer clone that repository and run all the things to be sure that everything is running correctly with what is working on. When all developers are happy with the new feature branch, they might want to merge the feature branch back to master and push a master branch to upstream so that Jenkins can kick in, run integration tests maybe in the cloud, so we are completely sure that we are going to run in a staging environment and live what is going to effectively run correctly. Jenkins create containers based on the pipeline that we discussed previously, and it uploads containers in the public hub private registry. It pins version of images in the repositories, and in that way it's possible to differentiate what image is running in development or staging, run tests, and containers are promoted to the next environment until they hit eventually live. So let's recap what we have seen. First of all, what I've learned is that all configuration management systems suck, and Ansible sucks just less. CoreOS is very easy to use and to run each available clusters. A pipeline to build a container is extremely useful because it allows you to run repeatable tasks and jobs. You can specify how to run services as desired with Docker Compose. And with service discovery, you can really run very easily systems in all environments that you want to manage. And that is all that I want. Thank you very much.
Any questions?
Thanks for the presentation. Nice one. So I had a question about Packer. With one of the things that you find with Dockerfile is that it saves intermediate steps, so it relies on cache. So rebuilding the same image is much faster. With Packer, because you're relying on Ansible or some provisioner, the entire building process takes a lot longer, and it doesn't support nested building. As in, if you look at Docker Compose, you can say that I link against the other service, so build that. So it will build that service first, and then builds the dependent services. So have you found any solution to solve that in Packer, where you have a list of services which needs to be topologically sorted and then built? Could you comment on that?
Yeah, actually, that is a very good question, because when you start playing with Packer, you realize that it takes really long time to converge, to get the result, to get your artifact. And this only solution that I came up with is to break the process down into small JSON snippet. So essentially, I create intermediate images. So if something goes wrong, I can restart from an intermediate step. That is what I'm doing right now. Not sure if anybody knows a better way. More than happy to improve.
Thank you.
Anyone else?
So my question is this, that basically, so all of this involves a lot of scripting. Basically, we write a lot of Puppet scripts and this and that, and it's like even Jenkins has a lot of scripts inside it. And the thing is this, that these things can be prone to a lot of bugs, especially if you want to add more capacity into a running system, or upscaling and downscaling systems as well. So how do you apply all of this to all of this? Basically, because this is software in itself, so you could end up with a recursive problem, because you need to be able to containerize and do all of this stuff to your CI system itself as well, right?
Not sure if I got your question correctly. Are you asking how can I scale that?
So my question is this, that how can you apply continuous integration to your continuous integration system?
That's an interesting one. Not sure if I can respond proficiently. I think that we need to discuss that offline, because I need to get a better understanding of what you really want to achieve. Yeah.
So I just wanted to ask your opinion in terms of where SaltStack stands and how we can use how SaltStack compares against Ansible and in your in the infrastructure that you've explained so far.
So I've never used SaltStack. I know that many people who are currently using Ansible like SaltStack because it allows you to scale to a very higher degree than Ansible allows you to do. So I have no personal experience with SaltStack. I know that it performs very well. That is.
Thanks.
And it's Python based. So.
So one of the things that I had against the continuous deployment using containers was that one of the arguments I got against that was that patching the servers becomes a lot difficult. So if you have services running on a, let's say a VM and have multiple services running there, especially applying security patches to the server becomes easier because you just have to patch the host and everything is patched. How do you solve that in the containerized environment?
So yeah, there are obviously a couple of approaches that you can adopt. Either you can store images in a private registry, but even though you are storing credentials in an image, which is not a very good idea from a security perspective. You can adopt services like Vault, etc., which allows you to store credentials in a much safer way, so that they are not stored on containers. Yeah.
Time for one last question. Nope. All right. Thank you very much, Simone.
Thank you.